Hello friends, I welcome you in lecture number 21 on random variables. In this lecture also we will discuss one more question on random variables which was asked in GTU Summer 2024 exam. So let's start with this question on random variables. The question is, verify that the given function is a distribution function. Distribution function means cumulative distribution function, which we shortly know as CDF, and it is denoted by capital F. So here we are given one function defined as fx equal to 0 if x is negative, and fx is 1 minus e raised to minus x by 4 if x is non-negative. And we have to verify that this is a cumulative distribution function or simply distribution function, and we have to decide these three probabilities also. So first we verify that this function is a distribution function, and to verify this function as a cumulative distribution function, we must recall the properties of cumulative distribution function. So to check whether given function is a distribution function or cumulative distribution function, we have to verify these properties. First property is that value of distribution function is always in between 0 and 1, and if we find out limit of distribution function as x approaching to minus infinity, then that limit is always 0, and if we consider limit of fx as x approaching infinity, this is always 1. Third condition is that distribution function is always right continuous at all the points, and another requirement is fx is non-decreasing function, that is fx can be constant or decreasing function. So if our function satisfies all these four properties, then we can say that it is a distribution function. I have written all these properties systematically here. The cumulative distribution function or CDF short form must satisfy the following properties: that value of CDF is always in between 0 and 1, limit of CDF as x approaching to minus infinity is 0, and as x approaches to infinity, CDF approaches to 1. CDF is always right continuous and it is non-decreasing function. So we check all these properties for this function one by one. First we can see that if x is negative, value of CDF is 0, and if x is non-negative, CDF is given by this formula 1 minus e raised to minus x by 4. So it is obvious that value of CDF is always greater than or equal to 0, because here we have e to the power minus x by 4, that is e to the power minus x by 4, and because x is non-negative, this quantity is always less than or equal to 1. Therefore 1 minus e raised to minus x by 4 is always less than or equal to 1 if x is non-negative. So it is clear that this property is satisfied. First property is that CDF is always in between 0 and 1. This is clear. Now we find out limit of CDF as x approaching minus infinity. Now when x is approaching minus infinity, that means x is negative, and if x is negative, value of CDF is given as 0. By the definition of given function, we have fx equal to 0 if x is negative. Therefore I am putting fx equal to 0 here, and 0 is constant, so limit of 0 is 0. And we have to check limit of fx as x approaching infinity also. So if x is approaching infinity, that means x is positive, and if x is positive or non-negative, CDF is defined as 1 minus e raised to minus x by 4. Now if I consider limit here, limit of 1 is 1 because 1 is independent of x, and this we can rewrite as limit of e to the power minus x by 4 as x tending to infinity. Now if we consider infinity here, then I will have minus infinity by 4 because x is approaching infinity and x is positive, so this quantity will remain positive here. And minus infinity by 4 is minus infinity, and e raised to minus infinity is 0, therefore we obtain 1. So this property is also satisfied, that limit of fx as x approaching minus infinity is 0 and limit of fx as x approaching infinity is 1. What is third property? Third property is right continuity. Now here we can see that fx is different in different intervals. If x is less than 0, fx is 0, and if x is greater than or equal to 0, fx is given by this formula 1 minus e raised to minus x by 4. So we can roughly see that if x is less than 0, suppose we have 0 here, then fx equal to 0, that is graph of fx is on negative x-axis. So on the left side of 0, we can see that fx is continuous if x is less than 0. Similarly, if x is greater than or equal to 0, that is on this side, we have this function, and this function is clearly continuous because exponential function is always continuous, 1 is always continuous, and difference of two continuous functions is also continuous. So if x is greater than or equal to 0, then this function is also continuous. So all we have to check is at x equal to 0. We have to check right continuity at x equal to 0 only, because to the left of 0 fx is continuous, therefore it is continuous. To the right of 0 fx is continuous, therefore it is right continuous. And all we have to check is at x equal to 0. So now we check right continuity at x equal to 0. So what we have to prove is that if we approach 0 from its right hand side, then limit of fx as x approaching right hand side must be equal to value of fx at x equal to 0. If this condition is satisfied, then fx is right continuous at x equal to 0. So first we find out this limit. This is equal to limit x approaching 0 from right hand side. Now when x is approaching 0 from its right hand side, that means x is positive, and if x is positive, fx is given by 1 minus e raised to minus x by 4. And now limit of 1 is 1 as x approaching 0. This is independent of x, and here we put x equal to 0, so we have e to the power 0, and this is equal to 1. And what is f of 0? F of 0 is also 1. We can see from the definition of the function, if x is greater than or equal to 0, fx is given by this formula. So at x equal to 0, if we put x equal to 0 here, we have 1 minus e raised to 0, that is 1. This means this is equal to f of 0. So what we have shown, that limit of fx, therefore limit of fx as x approaching 0 from right hand side this is equal to f of 0. This means fx is right continuous at 0 also, and at remaining points fx is continuous, therefore it is right continuous. So we can say that fx is right continuous. So we have shown this property also, right continuity, and last condition is fx is non-decreasing, that is either fx is constant or it is increasing. So for that we can use the concept of derivative also. For example, if we find out derivative of f, then what we will obtain? Here fx is defined in these two intervals. If x is less than 0, fx is 0, therefore derivative of 0 is 0. And here we have derivative of 1 minus e raised to minus x by 4. So again we write here 0 if x is less than 0, and if we differentiate this function, we have 0 minus derivative of e raised to minus x by 4 is e raised to minus x by 4 into derivative of minus x by 4 is minus 1 by 4 if x is greater than or equal to 0, and this is equal to, this is 0 if x is negative, and here negative negative positive, and we have 1 by 4 e raised to minus x by 4 if x is greater than or equal to 0. So we can see that derivative of fx is non-negative, and therefore fx is non-decreasing. And since fx satisfies all these properties, we can say that fx is a distribution function. We have to check all these properties to verify that fx is a distribution function. So this is first part of our question. Now what is next part? We have to calculate all these probabilities. First probability is probability that capital X is less than or equal to 4. So before calculating that probability, we recall the definition of fx. Fx is defined as fx at any point x is given by probability that capital X is less than or equal to x. So using this formula we can find out this probability. If we take small x equal to 4 here, this is equal to value of fx at x equal to 4. Now x equal to 4 is non-negative, and we have formula of fx here. If x is less than 0, fx is 0. If x is greater than or equal to 0, fx is 1 minus e raised to minus x by 4. So we are in this part because small x is 4. So we have to use this formula by taking x equal to 4. So I am taking x equal to 4 here, and I will obtain 1 minus e to the power minus 1, and this you can calculate using scientific calculator. You have to use shift button, and let me use scientific calculator. So I am using shift button, then exponential, then minus 1, and here I obtain 0.3679, and that I have to subtract from 1 minus 0.3679, that turns out to be 0.6321. So this is first probability which we had to calculate. Second probability is probability that capital X is greater than or equal to 8. So let's try to find out that probability using CDF. We have to find out probability that capital X is greater than or equal to 8. So this I can write as 1 minus complementary event of this event, that is capital X is less than 8, and this is equal to 1 minus this we can rewrite as capital X is less than or equal to 8, because we have capital X as continuous random variable, and we know that for continuous random variable probability at a point is always 0. And why I am writing in this way? Because I want to use the definition of CDF. So this I can rewrite as value of CDF at x equal to 8. We know that fx is nothing but probability that capital X is less than or equal to small x. So here we have small x equal to 8. So if we take small x equal to 8, this is nothing but value of CDF at x equal to 8. Now x equal to 8 is positive, so we have to again use this part. I will put x equal to 8 here, and I will have 1 minus e raised to minus 8 by 4. So I am writing 1 minus e raised to minus 8 by 4, and if we simplify this, 1 minus 1 plus e raised to minus 2. So this is equal to e raised to minus 2, and using scientific calculator I will obtain e raised to minus 2 as 0.1353 up to 4 decimal places. This is also approximately up to 4 decimal places. And the last probability we have to calculate is capital X lies between 4 and 8. So let's calculate that probability. Capital X lies between 4 and 8. Probability that 4 less than or equal to x less than or equal to 8. So you can see we have this type of situation. Suppose I have 0 here, 4 and 8. So I want to calculate probability between 4 and 8. So what I can do, I can first calculate probability up to x equal to 8, that is probability that x is less than or equal to 8. Now I don't require this part, so I will subtract that part from this. Probability that capital X is less than or equal to 4, and I will be able to determine this value. Probability that capital X lies between 4 and 8 can be written as probability up to 8. We will go up to 8, that is probability that capital X is less than or equal to 8. Now we require only this part, so we subtract this part, that is probability that x is less than or equal to 4, and this is equal to f of 8, and this is equal to f of 4 by the definition of CDF, and this is 1 minus e raised to minus 8 by 4, which we just calculated, and this is 1 minus e raised to minus 4 by 4. Let me rewrite properly. Because 4 and 8 are non-negative, I am using this formula which is given for x non-negative. First I am putting x equal to 8 and then x equal to 4 here. So this is 1 minus e raised to minus 2 minus 1 plus e raised to minus 1. So 1 will get cancelled, and here we have e raised to minus 1 minus e raised to minus 2, and we have e raised to minus 2, that is 0.1353. Let me write that first, 0.1353, and what is e raised to minus 1, that also we have calculated, 0.3679. So that also I will write 0.3679. Let me check again. E raised to minus 1 is 0.3679. Now let me take the difference of these two. 0.3679 minus 0.1353, that turns out to be 0.2326. So that is the required probability. So this is very nice question. This type of question was asked first time in this GTU Summer 2024 exam, and here we have to verify that given function is a cumulative distribution function, and for that we have to remember these properties. We have to check whether function satisfies these four properties or not. If it satisfies all these properties, then it is cumulative distribution function or distribution function. And to calculate these probabilities, we are using the definition of CDF, which is fx equal to probability of the event capital X is less than or equal to X. So this is all about this session. I hope you like it. Thanks for watching.